So now what we're going to do is talk about some other combining operators that are defined in the Flux class. We've talked about some before. Now we're going to talk about some more. And we're going to talk about reduce, collect list, and collect. And as you might surmise, these operators create a flux from multiple sources and typically they'll create something like a mono or something that consolidates everything together. We'll start with reduce. You've seen reduce before in the context of Java streams. The reduce operator in Flux is very similar, though of course not identical. The idea here is pretty much the same, though. You want to reduce the values from the Flux sequence that comes into reduce into a single object, which in this case is a mono, because that's a single object, that will be of the same type as the items that are being emitted by the stream. The reduction is performed by a by function parameter, and this parameter passed the intermediate result of the reduction and the current value, and this gets applied successively until everything is reduced. And here's just a quick little synopsis of this. So we would start out, for example, with the value 0, because that's what things get initialized to by default if they're integers. So let's say we had a flux of integers 1, 2, 3, 4. So the first thing we would do if we were reducing with an addition operator is we would add 0 to 1, which returns 1. We then take 2, and then we add that to 1. That produces 3. We then take 3. We add 3 to that. That produces 6. We then take 6, and we add 4 to that. That produces 10. So that's just a simple example of what's happening here. We're just reducing things by doing pairwise additions and then kind of bringing that down through the sequence of flux integers in this particular. The result of the flux is emitted from the final call as a sole item of a mono. So it makes sense. You reduce into a mono. That's a slight bit different than how things work in Java streams, where you typically reduce something to a primitive type. Because everything in Project Reactor is asynchronous, at least potentially asynchronous, we reduce into a type that itself is an asynchronous type, like a mono. If the flux emits no items whatsoever, the mono will be empty, which is perfectly okay. If something goes wrong, the internally accumulated value that's being created as we go through this process will be discarded if something goes wrong or if we get canceled. Now, something important to remember about reduce, if the upstream part of the stream of the flux never terminates, if it doesn't complete, then bad things will happen. So we're expecting things to complete. How could they not complete? If you have a generator that never finishes, right? So something where you didn't limit it by using take, or if you didn't have a fixed size data structure like a list or an array or whatnot. So in this particular case, it will in fact terminate because we have a list of big fractions, an array of big fractions we turn into a flux. We apply the flat map concurrency idiom to multiply everything together, and then we reduce it by adding things up. So we'll end up with a sum of the results of async multiplications, which will come back as a mono, and all is well because we terminated that. We ended up completing that particular stream. Sources that are infinite, like using the generate factory method operator we talked about before, that never complete, will never emit anything, and you'll probably run out of memory because it'll just go on forever and never terminate. RxJava has a reduce operator that works identically the same. And these are similar to the streams reduce operator, but the streams reduce operation or method doesn't return some async type. It returns typically a primitive or something like a long with a capital L. So you can see here that we have a list of numbers that we turn into stream, we reduce them, and we add them all together, and that gives us a result that comes back as in. The next combining operator we're going to talk about is something called collectList, which is pretty cool. It's very useful. It takes all the elements that are in the flux, and it will emit them into a mono to a list. So it returns a mono to a list that will contain all the values from the flux. And again, as with reduce, it's going to return it back as something that's an async type, a reactive type, like a mono. The list will be emitted by the mono when the sequence completes. So here's a very simple example. We'll look at more detail here in a minute. We take a list of big fractions. We do something to them with flat map. Let's ignore what that is. We then go ahead and get rid of all the fractions. We only allow fractions that are greater than 0. That's what the filter is doing. And we collect the results into a list. So we get a mono to a list. RxJava has a collect method that is a generalization of collectList. RxJava does not have a collectList method, but it has collect, and you can use it as follows. You can basically say, from observable flat map filter, collect to list. So that really looks a heck of a lot like the Java Streams collect operator, except it's going to return a single in this particular case, not a list. It'll return a single to a list. And these are very similar to Java Streams collect, except they don't return async reactive types. They return types like collections. So here we're going to have a bunch of numbers. We're going to get rid of numbers that are odd, so we only have even numbers, and we collect those numbers up into a list. And then finally, we have the collect operator. And this is a generalization of collectList, which collects all the elements emitted by the Flux into a container. The parameter is the Java Stream collector interface, and this interface defines supplier, accumulator, collector, and finisher. So those are the same things that you would have if you're familiar with Java collectors, because it's the same interface, identically the same interface. And the main difference between this collect in Project Reactor and collect that's in Streams is, once again, it returns a reactive type, mono, and the result will be emitted when the sequence completes. Why would we ever do this? Well, there's some interesting use cases here. You can actually use this particular operator to seamlessly integrate Project Reactor and Java Streams mechanisms if you so choose. And we'll see some examples of this later. So we have something called a monos collector, where you can give it basically a list of monos, which are all doing asynchronous processing in the background. And then you can convert those things into Java Stream style mechanism using collect. And there's also this same mechanism in RxJava that we just saw. And it's very similar to the collect method in Java Streams. And here's just an example where we collect these things into a set. So we collect even numbers into a set. Again, notice it's returning a set to integer, not an asynchronous type or reactive type like mono. That's the main difference, because Java Streams is really more synchronous than asynchronous in its core. All right, so that's the end of the combining operators in the Flux class. Very, very useful. We'll see some examples of those. And I believe that you'll use some of those in assignment number 4A, if I'm not mistaken. So we'll talk about that later.